In this video, I'll show you how to add task scheduling to your .NET or .NET Core application using the excellent Coravel task scheduling library. Welcome back to our channel. My name is Chris Roberts and this is Roberts Dev Talk. Now this video is part of a series where we're building a background service that monitors a storage queue for new messages regarding customer orders, then sends out confirmation emails. In the previous video, we started a new project based on the .NET Worker template, and so we'll be extending that one in this video. I'll be using Visual Studio Code and the .NET CLI. There's a link down below to go and get the .NET SDK. Any version 3.1 upwards will do the job. Also, I highly recommend you use the C# extension for Visual Studio Code, which gives you IntelliSense and C# debugging. With that, let's get started. Now first things first, in order to set up Coravel, we need dependency injection configured. Now in the previous video in this series, I created a very simple .NET Core worker service, which comes with dependency injection set up for us. Check out the link down below if you'd like to go and see that video. To install Coravel, we go down to our terminal and we run the command .NET add package Coravel. Now if you're using Big Visual Studio 2019, we can use the package manager console command install -package Coravel. Now of course, before we can schedule a job, we need to create it. So let's create a new class that will hold the logic for our scheduled task. So we'll click new file and we'll call our class process order.cs. Let's add a using statement using Coravel.invocable, and then let's create a new class process order. Now the Coravel task scheduler works with classes that implement the IInvocable interface. So let's base our process order class on that interface, IInvocable. Now let's click our IntelliSense icon and implement interface. Now as you can see, our invocable has a single method invoke. This is called by the Coravel task scheduler when the job becomes due. Also notice that it returns a task, which means we can make this method async and do asynchronous code within it. Now what we'll do for now is just create a very simple job that logs out a dummy job ID to the console, so we can see how the scheduler works. Now how do we get access to our logger? Now all of our scheduled tasks will just be registered in the dependency injection container. So each time our job becomes due, the Coravel task scheduler will just pull a new instance of our process order class from the container. This means we get access to dependency injection. So we can now just create a constructor, and inside our parameters, we can ask for an iLogger, which is the .NET Core logging abstraction interface, and the type for that will be process order. We'll call it logger. Now our IntelliSense wants us to add a new namespace, which is using Microsoft extensions logging. We'll create a private read-only iLogger process order logger, and we'll assign the value injected into the constructor to our local field. So now inside our invoke can remove the not implemented exception. Let's create a dummy job ID, and let's add the using system namespace to get access to GUIDs, and then we'll just add logger.loginformation, and we'll say starting job ID. Now notice we've got an error in our IntelliSense, and that's because the return type is task and we're not doing any async or await code inside the method, so we need to return a task. So we'll just return task from result true. So to actually use the Coravel task scheduler to run our job, we need to make some changes to the host builder. So let's go back across to program.cs, and we're going to add a new using Coravel. Now inside our main class, we need to get a reference to our host and then make some changes to it. So we're going to assign create host builder to host. We'll remove run, and don't forget to call host.run. Now the using Coravel statement has added some extension methods to our host service provider. So we can call host.services.useScheduler. And this takes an action as a parameter that configures our scheduler. So we'll pass in scheduler and open out that action. So inside here we can create the schedule for our process order job using var job schedule equals scheduler dot schedule, and then we pass in the type, which is our process order class, and then close that out. Now on its own, that won't actually do anything because Coravel still doesn't know when to schedule our job. But we've got some nice extension methods on the schedule that allow us some really flexible ways to configure when and how our job runs. So that's called job schedule. And notice we have a lot of methods here. Now, for example, if we wanted to schedule our job every day at 9 o'clock in the morning, we could just call daily at hour 9. And that would run every day at 9 o'clock in the morning. Now, if we didn't want that schedule to run on weekends, we could then call .weekday on the end of our method, and this would limit our job schedule to running every day at 9 o'clock, but only Monday to Friday. We can also pass it in a cron expression. We have methods to run our schedule every 15 minutes, every 15 seconds, and so on. But if we want to set a specific number of seconds between our jobs, we can select every seconds, and then for our process order, we want to run it every 2 seconds. Now both the scheduler itself and the process order job need to be registered inside the dependency injection container. So we'll go down to our configure services method, remove the default .NET Core worker. First we'll call services.addScheduler, and then we'll call services.addTransient, and then we'll pass in our process order type. This adds the process order type into the container, and transient means that every time Coravel requests an instance of this class from the container, a new instance will be constructed. So let's just have a look back in the process order job and remind ourselves what we want our job to do. So when the process order class is constructed, the container will pass in a logger, and then Coravel will call the invoke method. Then we create a new dummy job ID and we just log it out to the console and return. So if we run start debugging on our code, we'll see that's exactly what's happening. Our process order job is just printing out a dummy job ID to the console every 2 seconds. Our scheduler is now set up correctly. Now what happens if our process order job takes longer than the 2 seconds between our scheduled times? Well, by default, Coravel will always invoke our job when the scheduled time is hit. This means that if one of our process order jobs is still running and another one is started, you can have potentially 2 process order jobs overlapping. Now let's just demonstrate this by simulating a long-running job using task.delay. So we'll modify our invoke method by adding async to the definition, removing our return, and then we'll put await task.delay 3000 milliseconds. That's 3 seconds, which is 1 second more than the time between our scheduled jobs. And after our task delay returns, we'll log out that the job is complete. Job with ID, job ID is complete. So what will happen is that our job will start, and then the invoke will wait 3 seconds. But in the meantime, Coravel will start up another instance of our process order, meaning that 2 jobs will be running concurrently. So let's try this out. If we go to run and then start debugging, now let's inspect what's happened. So first of all, a job with ID 60524 has started up. In the meantime, while that's waiting to complete, another job, 5590, has started up. And then after 5590 starts up, 6052 then completes. This means that job with ID 5590 was started up while 6052 was still running. Now sometimes this is exactly what we want. It may not matter whether there are 2 jobs running at once, in fact that may be desirable, but sometimes it's important that our jobs run sequentially. Now to achieve this, we just need to make a very small change to our scheduled job. So let's head back over into Program CS, and then after our every seconds on job schedule, we'll add another extension method which is simply prevent overlapping. Now Coravel can be running multiple different tasks at once, so we just need to give it a unique name for our process order job, so we'll just call it process order job. And now if we run our code again with run start debugging, we'll just let a few jobs go through so we can see what's happening. Now we can see the job ID with 386E has started up, and then 3 seconds has passed and job with ID 386E has completed. Coravel has then started another job with ID 9BEC, and this has been allowed to complete. So instead of running concurrently, Coravel has prevented overlapping so that our tasks now run sequentially. In the next video, I'll be extending this example even further using the serilog library to log information to file and also send an email out when something goes wrong. If you'd like to see that, then please do subscribe, and we'll also update the description below when we upload the video. Thank you so much for watching. If you've got any questions, please do drop a comment below. Like the video if you enjoyed it, and we'll see you in the next video.